Hi everyone, in this video we are going to learn about basic data types and variables in Rust. Our first type is Boolean. Boolean is pretty straightforward as we talked in our previous video. We can have true or false values with Booleans. We are going to use Booleans mostly with control flows and particularly if-else statements. I'm going to say let my first bool and I'm going to say true and I can have a value as false my second bool false. I also remember I can always say like this here, so I can specify the data type here. Since we are not using these variables, Rust interpreter will give us a warning here, as you can see. But if we put underscore in the beginning, then it's going to be okay. That's basically me saying to the Rust that I know I'm not going to use this variable, so just don't warn me about it. So after this point, if you see me putting this underscore here, just know that that's what it means. Next, we have our integers. Integers are a little bit different in Rust. Normally, we would have in other programming languages just integers. So, and then we had floating point numbers, and if you're using Java, yeah, you can call it doubles too. So with Rust, it's a little bit different as we said. We can specify how much space we want for our integer. So in general, if you need that much of a space, you are getting this much of a space, whether you like it or not, because this much of a space can hold the maximum number for your integers and it's fixed. With Rust, we can say I need this big, or this big. So we have more functionality with Rust. But this functionality, great power comes with great responsibility. We need to manage our integer and memory management ourselves. But at first, if this seems a little bit intimidating, you can always create integers without specifying any type, which refers to 32-bit integers, which is I32. So in Rust, we can have 8 bits, 16 bits, 32 bits, or 64 bits, or 128-bit integers. So with 8-bit integers, what you can have is 2 to the power 8 different values. So 2 to the power 8 is equal to 256. It's not exactly half negative, half positive, because we also have 0, which is neither negative or positive. We are including 0 with the positive ones, so what we end up is 128 negative values, 127 positive values, and 0. And if we sum up these numbers, we can see it's 256. So this is the basic ideology. With this, we are saying we need that much place, and I know I can use the half of it for the negative numbers and half of it for the positive numbers, but just -1 because we are using that one for the 0. So let's create first 8-bit integer. I'm going to say let days, and I'm going to say I8 equals 7, and I'm going to say days of week. So it's more clear. So with this variable, I can go with I8 because if I'm working with days of week in this example, I know that I won't need that big of numbers, and I can use the smallest number here. But if I'm working with something larger, let's say the number of users, I'm going to say let number of users, so I can have many users. For that, I may want to say this is I64, and I'm going to say 128,000 for now. I hope it grows. Alright, so this is the different types, and as we said, we can use 8, 16, 32, 64, and 128. In Rust, we also have another type of integers. Once we said I8 is 8-bit integer, it's actually 8-bit signed integer. So signed integer means that our integer can be either positive or negative. But we also have unsigned integers. Unsigned integers can only be positive or 0. So for unsigned integers, if we say U8, which refers to unsigned, then we would have again 256 values because it's 2 to the power 8. But this time we are not occupying half of it for the negative numbers. So what we would have is 255 positive numbers and one zero. So if you know that you are not going to work with negative numbers, you can use u instead of I when you declare your variables. By doing this, you can use half of the memory for the same job, and it can be really useful based on what you are doing. In general, with blockchain applications and smart contracts, that's a very useful thing because we are not using negative numbers in smart contracts in blockchain. Alright, next we are going to create one variable with u type. I'm going to say number of tokens. Let's say that's the number of tokens the user is holding, and I'm going to say that's u128, so that's the biggest possible number that we can get, and then we will say 10,000 for now. So in this way we can utilize this big number, and if I need like less, I can say u not 164 but 64. So what can I achieve with I128? I can achieve the same number of positive numbers with u64. So it's more memory efficient this way. I'm going to put underscore here. And again, if we say nothing, let just a number. I'm going to say 0 here. Then it's automatically I32, so you don't need to worry about it. So as you can see here, it's a little bit different. It looks like more work for us, but I promise after you got used to it, it doesn't feel like a work at all. And what we gain on the other side is really, really big. The freedom of choosing the size of memory we want directly affects the performance and memory usage of our application. So we can be more effective and our program can be more effective. And if we don't want to use this functionality, we can just go with the default I32, which is really, really good in most cases. After the integers, we have the floating point numbers. For the floating point numbers, it's very similar to our integers, but here we just have 32 and 64. If I say let pi f32 equals 2.14, then I would have my floating point number with 32 bits here. In this case though, if I don't say anything, the default is f64 and not like I32 in the integers. Now we have the characters. So characters are also very similar to other programming languages. Characters in Rust are represented by the char type, which can hold any Unicode character. So let's create one here. I'm going to say let my char, which is not a very unique name, and the type will be char, but I don't have to specify it, as you know. And I'm going to say 1 here. It can be 1, it can be p, it can be any character you want, and this is all it can hold. And now we have the string type. Let's put underscores here because I don't like to see them yellow. So I'm going to say strings here, and let's put heading. Okay, now let's continue with strings. Rust has two built-in string types, str and string. The str is a reference to a string slice, while string is a growable string type. So these are different. String slice reference refers to a portion of string that is being referenced, and the string is the string that you know from the other programming languages like JavaScript or Python or any other languages, which can grow in size, which are mutable, and that's the classical version of the string. We have these two different types, and we are going to talk about in depth later about these types and how they are implemented. But to start with, I'm going to say let message, and this is the string slice reference, and we will say Simon here. Let's say hi Simon, so it actually says something. So this type is actually string slice reference. This is used when we talk about references, but we are going to talk about this more in our ownership topic. And this str is the string slice. This hi Simon is what you would expect to write your string. So because from the other programming languages, we got really used to write them like this, and that's what you would expect. In Rust though, if you write it like this, by default, it means that this is a reference to a string slice. So I'm going to delete this part here, And by default, it's the same thing actually. If we create a string, as you know from the other programming languages, which is mutable and it can grow in size, we would say let my string equals string from type. Alright, I know how it looks like. I know it looks a little bit different than the normal version, but after we understand how we can use this, why it's like this, it's actually much more powerful. And after we got used to these two different types of usages, what we realize is that half of the time, maybe a little bit more, maybe a little bit less, but what we need is this type, not the string itself. So, after understanding this difference, it's actually getting more comfortable and more handy. So don't worry about this, and let's look how it works here. So with this, it looks normal, but we said it's just a portion of a string, a slice of a string that we are referencing. That's what it is. And that's an original string. With this original string, we don't have this string type like we would have integers or floating point numbers, which is called later. So this is like this in many programming languages. If you look at C, C++, you can see that string is not native natural there too. So what happens is that we are calling this string here, and from the string we are calling from method. This from method transforms our string slice reference, hi Simon, to an actual string Simon, and by this we are saying we want to use function from string, and this is the thing that we are going to convert to string. As I said, there are many places that we want to use strings, and we want to use this type of references to a string slice. We are going to talk about them later in more depth, and by using them and seeing me using them, you are going to be comfortable about using strings and this kind of references. Next, after the strings, we have arrays. Arrays are similar to the other programming languages, so this is the part where we rest after strings. I'm going to create an array. I'm going to say days of the week, and we know how many days we have in a week. I'm going to say the data type here will be a string slice reference. I'm going to say the length will be 7. So here I specified which type that I'm going to have in my array. We can only hold one type. There is a workaround for that, but it's a little bit advanced topic, so we may talk about this in later weeks. But in general, what we should know that arrays just hold one type. And after we specify the type here, then we specify the length of the array, and then we define the array here. And here we are going to say Monday. Alright, here we have the days of the week. We have Monday to Sunday. I want to use this example here because if we are going to just use the days of the week, that means that we are not going to modify anything here. And as you can see, we defined them as a reference, as a string slice. And in this case, there is nothing wrong with it. And we can read from it. And since we are not making any changes with it, and we don't need this to grow in any sense, we can use this here. So I just want to show that there are many places that we can actually use reference to a string slice instead of a string. By being aware of it really helps you writing your code, which directly helps your code to be better. And if I want to get the first element from my array, what I would do is I would say let first element, and it's going to be, let's say, days of the week, and it will be 0. So our index notation is the same with other programming languages here. To get the first element, we are saying 0, which gives us the first element. Our array starts from 0, not 1. It's not index of 1, index of 2. It's the index of 0 and index of 1. By this ideology, if we go to the last, what we would have is length minus 1 instead of the length. So we can use this length minus 1 to get the last element of an array. For that, I'm going to say let last element. To get the last element, we are going to say days of the week, and here we are going to say length minus 1 because we know that the length minus 1 gives us the last element because our index starts from 0. And to get the length, I'm going to put the name of the array first, which is days of the week, and then I'm going to say that len. As you can see, it automatically asks for me if I want to use this function. So with this len function, I can get the length of this array, and if I say -1, which means that I got the length and now I got the -1. And by putting this here, I'm saying instead of 0, instead of the first element, I want to get the last one. Alright, and then we have the slices. So we actually talked a little bit about slices indirectly when we talked about string slice. That's a version of a slice. So that's the slice for strings, let's say. But we can have slice for many other data types too. And let's see slice of an array. I'm going to say slice here and let's say array here so that we will be consistent. And here I'm going to say let's slice. And for that, I'm going to use the days of the week example. First, I'm going to get the reference, and then I will say days of the week, and here I will say 1.3. Here, the elements I have is the element from the index 1 and 2, and 3 is not included. So once we set 1.3, it means that that's this 0, not this one. So I got Tuesday, I got Wednesday, this is 1, this is 2, and this is 3, but 3 is excluded, so I don't have this. I only have these, which are 1 and 2, and 1 and 2 here, and 3 is excluded. This way I can get a portion of an array. And to get an element from this slice, what I can do is I will say let first element of slice, and this will be the slice 0. It's just like an array. After the slice, we have tuples. So, tuples in Rust are a data type that represents a fixed size sequence of elements of different types. You can think of a tuple as a lightweight data structure that lets you group multiple values together into a single entity. Tuples are immutable by default, meaning that you can't modify the elements once the tuple has been created. So let's create our first tuple. I'm going to say let person here, and this is our person tuple. And here I'm going to say name of the person is Alice and the age is 30. And this is my tuple. This person tuple holds two different data types. The first one is a reference to a string slice, and the second one is a 32-bit integer. Here, to get the first element or get the name, I'm going to say let name equals person.0. And to get the age, I'm going to say let age equals person.1. So the first element is in a tuple. We can get it with a dot notation. It's just like the arrays, but instead the parentheses here we have the dot notation. And once I said 0, which means the first element. When I say 1, which is the second element with index 1 here. So that's how we can get the elements of a tuple, and if we modify it, we would do it the same way. And now we have the unit type. Unit type is a little bit unique to Rust. What we have with the unit type is just parentheses. So let's have an example. I'm going to say unit type here, and this is what I have. So this is how we can get a unit type, so we can check if this is type of a unit type or not. It's not directly used in many places, but it's sometimes used to make checks, and in our later lessons, there will be places that we are going to use unit type. Alright, now we have our variables. Variables in Rust also a little bit different. I know I said this a lot, but the three differences we have with our data types here is integers, strings, and finally variables in most cases. So here I'm going to say let num as the number 5 here. Then I said, yeah, it's a cool number, but I want to change it with 6. I should be able to do it. Num equals 6. Now, as you can see, I get an error here. If you look at the error, it says value assigned to num is never used, and this is our warning. But what our error is, cannot assign twice to immutable variable num. So what does it mean, immutable variable num? By default, in Rust, our variables are immutable. So we cannot change this variable here. Once we create it, it's fine. To change it, we need to define it with mute keyword here, which means it's mutable. After we define it with mute keyword, we are saying I'm creating a variable which is mutable and I'm changing it here. So I know it's a little bit different. If you use Java, the final keyword does the same thing. If you use JavaScript, the const keyword does the same thing. But in Rust, by default, our variables are immutable. And to make them mutable, we need to add the mute keyword. Why is that? So we are going to see why it's like this in our future lessons. But as a little bit spoiler, I can say it's really helpful for the Rust security on the memory management. So this is the basic data types and variable in Rust. Don't worry if you didn't get everything or memorize it in the first place. We are going to get very used to it while we use them in our later lessons. Thank you very much for now, and I will see you on the next one.